participate here and play a role in this. And David, that's a great question to start with. When I think about the vaccine, I really think of four parts to it. I think about the effectiveness, the durability, the safety, and then the distribution. And so let me cover each of those because I think that really gets at some of the questions you're asking and some that we'll probably continue to talk about during this next hour. The effectiveness of the vaccine, that's really where you started. And what you have to understand is that when they do these studies that are the trials, these clinical trials, they are going to look at tens of thousands of patients in the phase 3 trial. And it becomes a little bit of a numbers game because they're looking for they do something called a power calculation, which just tells them when can you say that this this vaccine is effective? How many patients do you need to actually vaccinate? And then how many have to get in the control group, how many have to actually get the disease of COVID-19 to be able to make that determination of what's 95% or 1% or anything like that. And what we know is that with any of these studies, we're looking at an endpoint which may not be the final answer. In all of healthcare, many things are introduced to the public and we learn more about them afterwards. And that's really what you're seeing here. This vaccine, and the two I'm going to talk about first are the Moderna and the Pfizer. And I'll talk about those together because they really are, in terms of their effectiveness, very similar, if not identical. We know they're, and what I would say is at least 95% effective. Now, if you look at the individual studies in the Moderna, there were 0 patients that actually got the COVID-19, whereas there was a couple in the Pfizer, and that gives you that 95%. But in fact, it is, as you say, probably even much better. But let me put that into context of other vaccines. Other vaccines that we regularly distribute for flu and for mumps, measles, all these other diseases actually are much less effective than this. They are in the 60, 70% range we consider to be an excellent vaccine. And so these two vaccines that have come out are as good as any vaccine we have. They are as effective in preventing the disease. And what we know is that even when it doesn't prevent the disease, those people that get COVID-19 who have been vaccinated have a much milder course. In other words, the disease is less severe. They don't go to the hospital. If they have to go to the hospital, and there's only been a rare individual who's had to go to the hospital that's been vaccinated, they don't go to the intensive care unit, they recover and they do much better. So this vaccine is extraordinarily effective in all of those measures. Now, durability is one of the other things I mentioned. How long is it going to last? How long are we going to remain vaccinated? Is that vaccine going to remain effective? And the answer to that is we don't know. So some vaccines are amazingly effective. You take one and it's good for the rest of your life. Other vaccines, you have to get a new one every year, or like the tetanus every 10 years. So this disease, we just passed the anniversary from the first case in the United States back on January 27th. This has only been around a year. There's no way to be able to assess the durability given that the vaccine just came out in November and December. So we're going to have to assess that. So what about the safety? And the safety is always a big question with vaccines. And this is a new vaccine, but I want to challenge that a little bit because we always talk about it being a new vaccine, this mRNA, so to speak, vaccine. We've actually been using mRNA vaccines for over a decade, mostly for cancer patients. What we know is that they're very safe, but we've actually tested them in very few patients because each vaccine is made uniquely for that individual's cancer. It's part of personalized medicine. But we know that those are very safe. So we've been using them for over a decade. But to be fair to everybody, we really don't know the full safety profiles for these mRNA vaccines. What we do know is that all of the studies suggest that they are very safe. There are people who have reactions to them. They're usually mild. There is an occasional, what's called anaphylactic reaction, or a immunologic reaction. Almost all of those are people who are sensitive to something called PEG, or polyethylene glycol. That's in many, many different other drugs and substances, and also vaccines. And so it's going to be a rare individual that will have an anaphylactic reaction. Most people get a sore arm, a fever, it'll last a couple days. You'll feel pain in your muscles, kind of just feeling really, really bad, but you get over it in a day or two at the most. So the last thing is the biology. The biology of these vaccines suggests the mRNA is that they're incredibly safe because our body makes mRNAs, these messenger RNAs, all day long, every single day, and our bodies are made to destroy them. And that's what happens with these mRNAs in the vaccines. So the last thing is that, so from my standpoint, and I have been vaccinated, I weighed the efficacy, the durability, which we don't know about, and the safety. And it was a very clear equation to me. Everybody should get vaccinated. Mm-hmm. Let me just address the last thing, was distribution. That's not necessarily an individual, but affects many of us. The Moderna and Pfizer vaccines, the way they're produced, require them to remain at very cold temperatures. We have heard that the data has come out on a new Johnson & Johnson vaccine. It's not as effective as the other two vaccines I mentioned. More in the United States, it looks like it's in the 70% range, 74%. But let me reiterate, patients who have gotten that always have a milder course. So just like the Moderna and the Pfizer, there is a tremendous value to the efficacy, and it's still an outstanding vaccine. The real value around that vaccine is that, first of all, you can produce much more of it much more rapidly because of the way it's made. The second is that it's much cheaper to be made, only a couple dollars a dose versus $30 to $35 a dose. And it does not require that extreme cold. So you can distribute it to many more places, like a doctor's office that may not have the capacity to keep things at this extreme cold, or as you're hearing now at CVS's and Walgreens and all kinds of other places where it can be distributed. So I think that once that gets a FDA clearance, we'll also see an opportunity to really increase the vaccine. Oh, and one more point, at this point, it only requires one dose, and they're actually testing the second dose because with the second, it may become just as efficacious as the Pfizer and the Modernas. We don't know that yet either.
Well, that's a terrific recap, Jeff. One of my personal rules in life when it comes to medical issues is I ask my doctor friends, would they take it on their body? And if they say yes, I say yes. And all my doctor friends are saying yes, and that's why I'm saying yes. When I hear you talk about the efficacy, I'm thinking, with the Jewish Journal and the Jewish community, I'm anticipating certain issues will come up. For example, this is going to have an influence on our lifestyles. More and more people taking the vaccine. What happens when Rosh Hashanah comes up and then synagogues may start to reopen? If I'm vaccinated by then, and hopefully I will be, should I expect everybody to be vaccinated in the shul that I go to, or the restaurant that I go to, or the office that I go to, or the Shabbat dinner that I go to? Or should I just take the attitude, well, I'm protected, and if somebody doesn't want to take the vaccine, it's their risk?
Yeah. So that becomes in part a sociologic question in addition to a medical question. And let me answer it in a couple ways. First of all, what should you expect? I think that we are going to be in a place where for at least the next number of months, and I can't say exactly, but I suspect it will last through Rosh Hashanah and Yom Kippur, we are going to continue to want to exercise the public health measures that are part of containing this pandemic that we are finding ourselves in. And specifically what I'm saying is masking, social distancing, and washing of our hands and space around us.
Even if you took the vaccine?
Even if you took the vaccine. And there's really a couple reasons why that's true. The first one is that, as I've mentioned, they're not 100% efficacious. And so you could be one of the people that get it. But more importantly, there is evidence that people who are vaccinated may be silent carriers. So you can actually have a live virus in you, but it doesn't affect you at all. And you don't know that you're actually carrying it. And then you have the risk of transmitting that to somebody who's sitting next to you or a child. Remember, the vaccine has only been approved for anyone over 16 years of age right now. So anybody under 16 right now cannot be vaccinated. So kids can be carriers. And we know that kids are carriers. They actually don't get very sick from it at all, from this particular virus. And as they're carriers, they may take it home to someone who has not been vaccinated, someone who can't be vaccinated because of an illness or some other reason. And so as we look to reduce this virus in our community, it is beholden on all of us to continue to follow those public safety measures until this virus, like we see the annual flu, basically disappears, and then it may come back. And I don't think it's unreasonable to think that this may come back on some type of an annual basis, or like the regular seasonal flu, but we're able to manage it.
So now the most important question of the day: if my mother gets the vaccine and I get the vaccine, can I hug her?
Absolutely.
Okay. This is now, it's worth my while. This is, I got to tell you, I'm only half joking, because the hug is one of the most important things in human relations. Being able to hug our kids, our best friends, our parents, our grandmothers, and that's been taken away from us. And if there's one thing I'm really looking forward to, when we get vaccinated, is to be able to hug again. Now let's move to the main subject of today.
But let me, David, if I can just make one little statement about that. You can hug, but make sure you've waited till after those, at least 14 days after that second dose of your vaccine, because that's when the tests show that we know you've got the immunity.
Absolutely. My mother wouldn't let me otherwise. So let's go to the main subject of today. Sometimes I feel this stuff is inevitable. It's like a war. When you develop a really strong missile, the other side develops a radar or anti-missile defense, and then you develop a better missile to fight that defense, and they develop a better defense. I wonder, there's something that almost feels inevitable. We come up with this incredible new idea, with the vaccine. And were you surprised by the fact that variants came up so soon? Or did you say to yourself, this was inevitable?
This was definitely inevitable. And let me explain why. This virus mutates every single day. It is always mutating.
Explain mutates.
Absolutely. Every living organism or anything that's living has a genetic code that is the blueprint for how you're going to make yourself. So we, as humans, have about 3 billion what are called base pairs. That's the DNA that for us is on 23 chromosomes. It's 4 base pairs, or 4 different types of base pairs. You may have heard them, A, C, G, and T. I won't go through the details of what those are, but they're 4 different molecules that are lined up in a specific order that give the instructions to make us and to keep us alive and all the physiology that happens within us. The virus also has a genetic code. it's only 30,000 base pairs, and they're RNA instead of DNA. We make RNA, but from our DNA. The virus only has RNA. And that RNA, 30,000 base pairs, so it's about 1,000 times smaller than our own genetic code. But sometimes those base pairs, that A, C, G, and T in us, A, C, G, and U in RNA or in this virus, will change. So an A will become a G, or a U will become a C. And those changes can change what it encodes, so the protein it makes, and then that protein changes its function a little bit. And that's what a mutation is. And that mutation can be in one of us, and that can cause cancer. And those happen all the time, as an example. And those happen all the time in us. But we have ability in our cells, in humans, to actually correct those mutations, to correct those base pair changes. Or if we don't correct it, a cell becomes abnormal because it expresses an abnormal protein, and our immune system goes in and removes that cell. So even though we make these abnormal cells, or we have these mutations every single day in our body, they're all removed.
Got it. So
the virus, the virus does this same thing every single day, except it replicates and mutates faster than we do. So to see one of these emerge as a new variant is not unexpected. And what's important to recognize is almost all the mutations that occur every day that are always happening in this virus either are what we call silent, so they have no effect at all, or sometimes, and oftentimes, usually, they make the virus less infective. It's rare that you get one that becomes more infective, but they do happen.
Okay, so the principle of that image that we've all seen now all too often, where you have these spikes that come out of the COVID-19. They're like these protein spikes, and those spikes are really the danger weapons that kind of do damage, right? And then the vaccine kind of creates a safe space, like target practice, thanks to Professor Levy from Shaare Zedek in Jerusalem, who explained it to me on a podcast. It's like they create these quote unquote safe spikes to give our immune system target practice. So when the bad ones come, we're ready to fight them, right? So when you have a variant that's dangerous, from what I read, there's but 3 variants now that are dangerous. There's one in England, I think forget the name of it. What is so different about a dangerous variant than the regular COVID-19 that the vaccine is prepared to fight off?
Yeah. Paul, I don't know if you can pull up the one slide towards the end of my presentation that looks like a cartoon. But let me try and explain that. These spikes that are on the outside of the virus, this virus structure, those spikes are what, if you could go to about the 5th slide, I think it is, or 6th slide.
In the meantime, I got a question. Is the virus an organism? It's not a live organism, correct?
No, go back to, Paul, sorry. Yeah, stop there. So viruses are organisms that can reproduce, that they are an organism, but they're parasitic in the sense that they're dependent on the cellular machinery of another organism. In this case, humans, or maybe it's a bat, or it's a dog, whatever. They themselves cannot replicate. And so if they're not in a cell of another organism, then they'll die off.
Great.
And that's one of the things about what we want to do with this pandemic and with these vaccines is we want to reduce the total number of viruses that are getting into cells, because they only will mutate when they're in a cell. They don't mutate when they're on their own. When they're on their own, they're basically static until they get into another cell.
Okay, excellent.
Yeah. So hopefully people can see this real quickly. The green is actually that spike protein. That's what the protein actually looks like. That's a group of amino acids. Those spike proteins actually interact with the receptor on the human cells, the so-called ACE2 receptor. So this is how a virus actually enters into a human cell. It uses that spike protein, and there's a special part of that spike protein that's right between the green and the red, and it's called the receptor binding domain. It's where that spike protein attaches to the surface of a cell and then gets ingested into the cell and then basically usurps, it basically takes over the cellular machinery to reproduce itself. And in doing that, it usually ends up killing that cell, although not always. Now, what you can see, these are two mutations that we have found in this particular the variant that actually we identified at Cedars Sinai that's now called the California.20C variant. This one has also led to an explosion in cases starting in Southern California, but moving all across the world, first the United States and then the world. And I'm just showing these two mutations. If you look at the one on your left, and you can see it's highlighted in purple and exactly where that mutation is. It's not important, but it's called the W152C. You can see that that's kind of off to the side. It doesn't play a role in interacting with the receptor or anything else significant. But the mutation on the other side, the L452R, you can see it's right where that protein, where the spike protein interacts with the cellular receptor, the protein on a human cell that's going to allow that virus to attach and go into the cell. Those are the type of mutations that we worry about. And those are the type of mutations that can result in these new variants becoming more infectious and potentially lead to a more serious disease, although that hasn't been the case. But they do seem to be more infectious. When you develop a vaccine against this spike protein, it actually creates an antibody in your system. The antibodies are another protein that our immune systems make. And we make them to go directly to that particular receptor binding domain. And these are big proteins, these antibodies, and they sit on the surface of the virus, spike proteins, and they obstruct it from being able to attach to that receptor. So now these viruses are incapable of actually attaching to and getting into our cells, and then they can't divide and infect other people.
Okay, so I think it's important to establish a caveat here, Doctor, that there is still a lot we don't know, correct, about the variants. But from what we know, the state of science today, how worried are you about the effectiveness of the current vaccines to fight off these variants?
Yeah. You're absolutely right. We don't know, but let's talk about what we do know. What we have seen we can actually test this. We can model this in the laboratory. So we can take human cells that express that receptor and we can put the different viruses on, and then we can add antibodies that have been produced from patients who have the vaccine. And when we do that, we know that for this California variant that Cedars Sinai identified, but also for the UK variant, that these two vaccines seem to be just as effective as they are against the original, the strain of virus that doesn't have those mutations. Mm-hmm. That's not 100% true for particularly the South African variant, and likely for the Brazilian variant too, which is the other P1, which is the other one that's emerged around the world. For those, the vaccine is less effective in preventing disease in total. But what has been shown, parenthetically, is that those patients who have been vaccinated get less sick, just like we see from those few patients that have gotten sick with the vaccine. So even with those vaccines, you have the patients do much better than they did without the vaccine.
You know, one of the things that's been in the news is how come Israel has been so successful in the speed of getting their people vaccinated. From the latest numbers I've heard, you know, if they're at 30%, the second is not even half of that. And then they've really like lapped the field. It's been an unbelievable accomplishment. That's already pretty well known. And when we try to do some research to find out why that happened, one of the things I've heard is that because Israel is able to collect a lot of data, first of all, they have an ID card. They're able to really collect tremendous amount of data. So a company like Pfizer has an incentive to give a lot of vaccines to Israel because they'll be able to gather so much data on side effects and so forth. So do you see Israel as playing a key role in determining the future effectiveness of the current vaccines for these variants?
Yeah, so first of all, Israel has done an amazing job. And we should all be really proud of Israel for what they've done. You know, in contrast, the 30% you mentioned, right now in the United States, we're somewhere just under 10% for first dose across the country. And for people who've gotten the second dose, I think we just hit 2%. So we're really, really behind in where we are. And there's a number of reasons for that. And I think you've hit on one of the key ones, which is the fact that we do not have a universal health record that allows us to trace and follow all of our patients. We have these disparate medical records and systems that don't allow that to happen. Israel is so far ahead of us in their ability to do that. So what role will they play internationally in helping us understand this pandemic? I think the first thing that's going to be most important is they're going to help us really understand what the side effects are, if any, both short and long-term. We didn't talk about long-term, but you know, there's always potential for long-term side effects. Are there any at all? And what are they? And I think Israel will be ahead of everybody else. And not only because they've distributed, because I think eventually we'll distribute a large enough number here to follow that, but because they have the capability to actually follow up with that information. Mm-hmm. The second thing is that they will play a major role in understanding what the durability of the vaccine is. Again, because of this ability to track their the individuals in their country. And then the third one will be, what is the real effectiveness of it? And as you alluded to at the beginning, or maybe Paul said it at the beginning, I forget, it looks like based on the early results from Israel that these two vaccines are actually better than the original safety studies. And again, I want to emphasize, those safety studies are based on a limited number. Now, instead of doing what was 70,000 between Moderna and Pfizer for the two safety studies, now we've got millions to look at. And so we have a lot more information, and they're actually looking better than they were before. So absolutely, Israel is going to play that important and key role. And it's fantastic they can do it. I only wish we could do it here.
Well, speaking of what you're doing here, I was trying to imagine the kind of position you are in at Cedars Sinai. Last week, I was reading that LA County was actually the worst county in the country in terms of infections. And then you have to deal with the infections that keep coming in. And at the same time, you have to deal with the vaccine and the research that you're doing on the vaccine. So I'm curious if you can talk about what is what is your top priority now at Cedars Sinai? Do you have this kind of dual track? Let's kind of take care of people who get sick and let's vaccinate people who are not. And how do you manage this delicate dance?
Yeah. You know, as a really world-leading healthcare center, we have a responsibility for all of that. And our number one priority is always to take care of our patients. Anybody who comes to Cedars, we have to take the best care. They have to get world-class care, and they do. That's our number one priority. But as we're doing that, we also have a commitment to vaccinating, to first to keep our healthcare workers safe, because if our healthcare workers are not safe, then we cannot take care of our patients. Mm-hmm. So that's a critical element of us getting where we started. We've actually done an outstanding job, and virtually all of our healthcare workers are now vaccinated. Certainly those that want to be vaccinated, they've all been vaccinated. The second thing is vaccinating those people who are at highest risk. And that risk stratification becomes a very complicated, again, sociologic question. How do you measure who's at highest risk? Do you do it as a number of years they're expected to live once they get the vaccine? Do you do it on people who are at highest risk? We know that the elderly over 65 are at the highest risk. Those are the people that come to the hospital most, go to the intensive care most often, and actually most often succumb to this disease. Mm. So there's your high risk people. People with underlying conditions, hypertension, diabetes. These are the underlying conditions that we are most concerned about. So identifying our patient populations that we care for, making sure they get vaccinated. But then Cedars Sinai has a responsibility to the community beyond those high-risk patients. We're responsible for our entire community. And so we've set up the stations that will allow us to vaccinate thousands of people a day. We can probably do somewhere around 30,000 people a day. Wow. In several of our locations, or together in several of our locations. That becomes the challenge of getting the vaccine. And so there is where we are, that's our bottleneck now. Mm-hmm. So we have deployed the resources, we've put the infrastructure in place to manage all of that. Now what we're waiting for, and I know people are frustrated, I'm frustrated, all of us at Cedars are frustrated. We need to get the vaccine. Once we have the vaccine, we can get it into people, and we will.
Well, I think we should ask Paul Jesser to pull some strings and get us a direct shipment from Israel, Paul. See what you can do. Put that on your to-do list. Straight to Cedars. Dr. Golden, I do want to ask you a question. The conventional wisdom is that we've made tremendous progress in terms of treatment. And that means that the fatality rates have gone way down, right? Yes. That is the conventional wisdom. You have tracked this very closely from the beginning. Can you tell us from a scientific standpoint, how true is that?
Yeah, it's absolutely true. Let me give you a couple of examples of how we've changed how we treat patients today versus last March and April. Last March and April, patients that were really sick and in the intensive care unit would not get steroids. Steroids are very good at suppressing the immune system, and we generally were very concerned about giving steroids to anybody who has an infectious disease because it's your immune system that's fighting that infectious disease. But what we've learned through studies that have been done at Cedars and elsewhere is that it's not just the infectious disease. As a matter of fact, a major part of what makes people sick is the immunologic response that's generated by this virus. Mm. And actually just yesterday, there was an announcement of a new drug out of Israel that actually was extraordinarily effective at reducing that immunologic response in 29 of 30 very sick patients with COVID-19. Mm-hmm. Some moderate, but most very sick.
And if you can elaborate on that, doctor, I think it's really, I mean, as an amateur philosopher, I kind of, I'm in awe of that idea that when our immune system almost panics, right? And then it overfights, correct? And it's that extra, I don't know what they call it, a storm or something, right? And that ends up backfiring. It's so fascinating to me because even in real life, it's the panic, it's the anxiety, it's the thing that ends up hurting you when you're dealing with conflict and problem. And it's just so ironic to me that even in our biology, that principle still operates.
Correct. So it's called a cytokine storm. Cytokines are these molecules that actually turn on the immune system. And so what happens is that when you get an infection, you get cytokines that turn on the immune system to go and attack and get rid of these pathogens, the virus or the bacterium or the fungus or whatever you have. What's been shown in this particular, with this particular coronavirus is that it hyperstimulates that cytokine system. And that cytokine system causes an inflammation in your body in blood vessels throughout your body, which has been responsible for the strokes and the heart attacks and many of the other things that were associated with this particular virus. But it wasn't due to the virus, it was due to what the virus did to our immune system.
Wow.
And that gets back to what I was saying about this giving steroids, which suppresses that. We now do it much earlier, and we know that that takes care of patients much better. Another thing that, I mean, these simple things we learn. Most patients, if you see a patient in an intensive care unit and they're intubated, and many patients unfortunately had to be intubated, they'd be sitting up in their bed. What we've learned is that sometimes we can even avoid intubation by turning people and putting them on their belly. I was amazed walking through our hospital, seeing patients, instead of being laying on their back, they're laying on their belly. But for whatever reason, with this particular coronavirus, they did much better. And we actually prevented many people from getting, having to be intubated, which was a bad sign with the coronavirus. So now we're treating these patients very differently, and we are doing a much better job because we've learned about it. Remember, this disease has only been around a year, less than a year for us to really understand and study it. And so as we learn, we're deploying what we learn immediately to caring for patients. And it has made a tremendous difference in the outcome for these patients.
David, in about the 10 minutes we have left, let me just ask some of the questions that we've gotten from those participating. And then I want to show a slide that Dr. Golden prepared. I want to ask him to make a comment about it. But two of the questions: when you breathe out droplets, does the virus detach from the droplet to find another person to affect? And the second question: if social distancing with masks continues even after vaccination, how do you reconcile hugging?
Paul, I'm having a little bit of a hard time hearing you. So the first question was about the droplets and whether if they infect another person?
Yes, let's do that one first. So
this is one of the areas that we've learned a lot, and it's changed a little from the very beginning. At first, actually, if you remember at the beginning of the pandemic, we didn't even recommend masking because we didn't think that that was how this was transmitted. And then we moved to where everyone has had masks because we've learned about this. There's different kinds of droplets. There's very small, tiny ones that stay aerosolized, and there's very big droplets. Now, when I say very big droplets, they're much smaller than the head of a pin, a needle, and so they're not something you can see. But those don't stay in the air. They drop very quickly. They don't spread more than a foot or two from your body, from your mouth when you express them. The majority of this virus lives in those very heavy droplets that just fall in front of you. And that's why it's important to clean, not only wash your hands, but to wash the surfaces around you. It used to be thought that in these small fomites, these small droplets that were aerosolized, that you did not have COVID in them. That's not true, but we do know that it's less. There's less of it. And so when those droplets go, they can still infect someone else. It looks like when you get infected with those, you may get a lower dose of the virus. And so the course of COVID-19, the disease is less, but that's still something we're trying to understand. But the answer is there can be COVID, the virus, the SARS-CoV-2 in both those ones floating in the air as well as the ones that drop down. But the majority are in the ones that drop down, and only a few get out into the air that can infect people. And that's probably not a major spread. The bigger ones that drop down, those are a significant spread of the virus.
All right, let me just pull up this one screen, which I found fascinating, and ask if I can get it. There we go. Hold on. Can you explain? This has obviously to do with the variants. Can you explain what this is about?
Sure, absolutely. So this is a map over time of the spread of this particular variant that we found in Los Angeles. So we found it at Cedars Sinai. And what's important to recognize is that it started in October. There were 4 cases that we identified at Cedars Sinai. Before that time, there had only been 1 case, and it was identified in July at Cedars Sinai. As you look at November and December, you see that bubble in California growing, and you see it spreading. It's now in Nevada, it's now in Utah, and you even see it moving over to Washington, D.C. By December, it's in even more states, and you can see the bubble growing. And I'm going to ask to show one more slide after this, but what you can see is by January, so by the end of December, roughly a little over a third of all cases of the disease, COVID-19, were due, this particular variant that we identified was responsible in Southern California for a third of all of those diseases. By the middle of January, or getting towards the end of January, January 22nd, that bubble gets even bigger. You can see a huge outbreak in Arizona. It's almost 50%, between around 45% of all cases in California were due to this variant. This is behaving like the UK variant, spreading very rapidly, becoming more and more prevalent in our population. This is a type of virus that looks like it doesn't necessarily cause a more severe disease, but it is more infectious, or it appears more infectious. And in the last one, the last one in the lower right, you can see it's not only spread from the United States, it can now be seen in Singapore, in Australia, in New Zealand. And in fact, at this time, we know it's in Denmark, it's in the UK, and it's many other places. If you can go to, I think it's the next slide, or maybe it was the previous one. Sorry, go back to. Yep. No, this one right here. What you can see here is the spread in Southern California. You can see the percentage of this virus as we go into January, going from essentially not being here at all, but because of this mutation. This is actually 5 specific mutations that define this particular variant. These 5 mutations resulted in this extreme rise in the number of cases being responsible by this particular virus.
Okay, so these are the percentage that are the variants, correct? And from what I hear today, so far the vaccine that we have now look effective with these variants, but you're keeping a really close eye on it and measuring it?
So the modeling that we have done suggests that the vaccine will actually be very effective against this particular variant, the Cal-20C. We are actually right now doing the studies in the laboratory to prove that. Okay. So we haven't proven it yet, but the modeling, so essentially a mathematical modeling, a theoretical modeling suggests that yes, that vaccine should be just as effective against this particular variant.
Well, Paul, when they get the proof, I want you to let us know.
Yes. David, time for one more question.
Oh, is that for me or for the audience, Paul?
For you.
Okay. Well, If it's for me, I want to ask you a personal question, doctor. How this has changed your life? You've been a doctor for a long time. You've seen so many cases. You've been involved with this stuff. I mean, your whole career. And then all of a sudden, this hit. Tell us how this has changed your life, how this has impacted you personally. And is this something that medical school prepared you for?
So no one here has lived through, I expect, anything like this before. It has impacted all of us. And it's impacted me personally in different ways at different times. So for example, early on in the pandemic, we had to shut down all research because we didn't know so many different things that we know about now. And so we shut down all research, and the only thing we kept open was any research that was only on COVID-19. And this has a huge detrimental impact on science and healthcare, because many studies are longitudinal that require years, and they're dependent on each step. And if you lose something, it can set you back months or years. So this was a major, major impact on research. But what it's also shown me is the tremendous just outreach of humanity. Because when it first started, all of those investigators, all of those people that worked in labs, graduate students and postdoctoral fellows and everybody volunteered and went and started helping take care of patients with COVID, whether you were just registering or whether you were distributing personal protective equipment, so-called PPE, masks and gowns and shields and all that, whatever it was, you saw everyone wanting to participate, play a role and help, because everyone knew what this meant. And so I think it's had an impact everywhere, from showing the importance of science to the importance of humanity.
You know, doctor, I'm a religious Jew. I love the Sabbath. I believe in God. I believe in the power of God to even protect us, the power of prayer to protect us. But I have to tell you, I've never been more proud of science. And when I think of these thousands and thousands of scientists around the world that burn the midnight oil, that spend countless hours in the laboratories to kind of save humanity, it gives me the goosebumps. And what I tell my religious friends is that they're using the gift that God gave them to save humanity. And I salute you, as a representative of that scientific world, that you were able to do it so quickly. Because I promise you, 6 months ago, you know, in the journalism world, we were expecting hell for 2, 3, 4 years. Nobody could ever have imagined that by Hanukkah, we would have a vaccine with 95% effectiveness. And since you're the scientist in this Zoom session, I want to just salute you and everyone in your world that has come to the rescue and that has really stepped up to save all of us.
Before I give Dr. Golden the final word, I want to thank all those of you who have joined us. This has been a very important topic, and I want to thank David for being a partner in crime. He and the Jewish Journal have always been very supportive of everything we've done, and having David involved in a program like this adds much to it. Dr. Golden, you've been in LA 4 months. We hope to get a chance to get you involved in all of our communities and all of our communities' activities. When we have a chance and when we can do this, you, David, and I will go out for a little drink just to meet each other personally.
Or Shabbat at my house.
We want to thank you so much for participating. As I started off, I don't know, many of you were not on when we started, but I wanted to mention that Dr. Golden's mother was a life member of Hadassah. And although Hadassah and Shaare Zedek are friendly competitors, both of the hospitals have worked to take care of the patients, the citizens of Jerusalem, and I think have done a wonderful, wonderful job. So Dr. Golden, we'll leave the last word for you.
Well, first I want to say I'm as surprised as anybody at how quickly the vaccine, I think everyone who is in the medical world is shocked by how quickly this has happened, but certainly delighted. And I would just say thank you to everybody on the call today. I think it's really important that you continue to support science, continue to support healthcare, and continue to play your role in helping us defeat this pandemic, or to basically eliminate this pandemic by getting vaccinated, and at least for now, following all of those public health measures. So thank you very much, and look forward to working and interacting with all of you again.
One final word of appreciation to Dr. Shlomo Melmid, who helped us put together this YouTube program and this Zoom program and the one beforehand. We appreciate Shlomo's support. David, any final word before we close off?
The final word is test negative, stay positive.
Thank you. Everyone have a wonderful day. Root for Tom Brady, and who comes from Dr. Golden's backyard. And we hope that you all stay healthy and stay safe. Thank you for joining us.
Bye-bye.
Thank you.